In last video we discussed about two cases of motion inside an elevator. Now the third case, as we saw that in the previous video, that when the elevator moves in upward direction, the apparent weight of the person increases if the elevator moves with an acceleration, and if the elevator moves downward direction with an acceleration, then the apparent weight of the person reduces. Okay. Third case, if the lift is moving in upward direction with constant speed. So for upward motion, if you remember, we have this equation. Okay. But the question is that here the elevator is moving with a constant speed. So if the speed is constant, that means its acceleration is 0. Alright, a should be 0. And if we substitute a as 0 in this equation, finally r is equal to only mg. That means the apparent weight of the person becomes only mg, which is also true for normal situation. Normal situation means when the lift is at rest. Okay, so that means we can say that the the apparent weight of the person remains equal to the real weight when the lift is moving upward with a constant speed. Next one, when the elevator is moving downward with a constant speed. Speed is constant, okay? So if speed is constant, in this case also a will be equal to 0. Fine. And for downward motion, we have this equation mg minus ma. So in place of a, we should substitute 0. So this term will be 0, and finally again we are getting r is equal to mg. So there is no change in weight of the person. Okay, because mg is the general formula for weight. Another one, the last one, when the lift is moving in downward direction with an acceleration equal to acceleration due to gravity g. Okay. So here also the lift is moving in downward direction. So for downward direction we have this equation, this one. Fine. But it is given that the acceleration of the lift is equal to g. That means a is equal to g. Here in place of a, if we substitute g, this becomes mg minus mg equals to 0. That means the apparent weight of the person becomes 0, and this condition is called weightlessness. Okay, this weightlessness condition sometimes we feel when we are inside, or we are moving in a giant wheel. You know this one, right? Giant wheel. So there also sometimes when it comes down, we feel weightlessness. Alright, so remember this thing, that when the lift is moving downward direction with acceleration due to gravity, then what happened is, we know that this one, the person will feel weightlessness. Okay, next let us see one question, this one. A person of mass 60 kg. Okay, another thing you remember, that mass of a person is given in kg, but weight is given in Newton. Okay, and generally when we say that weight of this person is 60 kg, we say like weight of a person 60 kg or weight of a person is 70 kg, but though we say weight, it is not actually weight, it is actually mass, because we are saying it in kg. Okay, anyways, let us see this sum. A person is there having mass 60 kg, moving inside moving in an elevator in upward direction. Alright, the acceleration of the elevator is given 3. Find the apparent weight of the person. Simple question. G you are asked to take 10. So in sums, if you are asked to take G as 10, then only you take it as 10, otherwise take 9.8. Anyways, for upward motion, we have this equation. So here m is taken common, this will be g plus a. So g is 10, 10 plus 3, acceleration is 3. Okay, so if you calculate, the value comes as 780 Newton. So in this way we can solve these sums considering this equation or the equation for downward motion. Thank you.